Hello everyone, welcome to the new video of Data Analytics. Today's video is about how to test the normality assumption of the data. The normality assumption of the data is tested for the Likert scale variables. Here the Likert scale variables are affordability, applicability, accessibility, availability, accountability and acceptability. These are all the sub-dimensions of the main variable adoption level. Therefore, here we want to check the normality assumption of adoption level. Let us move to the steps. First of all, click on the Analyze, then Descriptive Statistics, here Explore. Then from the left side, we have to click on the adoption level and move on to the dependent list. Click on the plot. Here we can see histogram and normality plot with test. Select these two dialog boxes. Then click on continue, then OK. This is the output view of normality analysis. Here we can see the different results for measuring the normality assumption. First of all, the case processing summary. Here we have selected adoption level as the variable. Total n number of samples, that is 100 sample size is there. And the second column is about descriptives of adoption level. The mean is 3.48 and median 3.49, variance 0.364. Standard deviation 0.603, minimum value 1.94, maximum value 4.83, range 2.89, interquartile range 0.79, and the skewness value and kurtosis value, and the standard error of skewness and kurtosis value. Whenever we have to check the normality assumption, this is a very important column, the test of normality. Here we can see that two important statistical tests, namely Kolmogorov-Smirnov and Shapiro-Wilk test. These two statistical tests have the values of statistics, degree of freedom and significance value. Regarding Kolmogorov-Smirnov test, the statistical value is 0.052 and the significance value is 0.200. And regarding the Shapiro-Wilk test, the statistical value is 0.993 and the significance value is 0.896. And the null hypothesis will be data is normally distributed. The alternative hypothesis, data is not normally distributed. Since the p-value is greater than, p-value means the significance value which is greater than 0.05, that means failed to reject null hypothesis. Therefore, we can assume normal distribution. Whenever the p-value is less than or equal to 0.05, we have to reject the null hypothesis. That means data is normally distributed. Here, both the tests should ideally show the p-value which is greater than 0.05. Hence, we can assume the normal distribution of data. And furthermore, the Shapiro-Wilk test is applied when the sample size is less than 50 or Kolmogorov-Smirnov test is applied for large samples and it will be applicable for large samples. And again moving to the histogram. Here we can see the histogram of adoption level. The data appear roughly symmetric and somewhat bell-shaped. Therefore, it's suggesting a normal distribution. Here the mean value is 3.48. Standard deviation is 0.603. The range of adoption level is in between 2 to 5. Hence, we can conclude that most values cluster around 3 to 4 with the frequency peaking near to 3.5. Overall, the distribution looks fairly normal, but it will be more precisely said that when the Kolmogorov-Smirnov test is applied. And moving to the stem and leaf plot. The stem represents the 10-digit adoption level and leaf represents the units digits. Each row shows stem value with the corresponding the leaf value. The frequency indicates how many observations are represented by the leaves for each items. From the plots itself, most adoption level are in the 30s range, that is the highest frequency. All the values are range in between 19 to 48. Therefore, the distribution seems somewhat spread out of 30s with a concentration of values. Therefore, we can say that the normal distribution for the data. And moving to the normal QQ plot. Here we can see that all the points in the plot are closely follow the straight line. This indicates the data for adoption level is approximately normally distributed. Deviation from the line at the end could suggest minor departure from the normality in the trail, but overall the data looks pretty normal distribution. And this is the detrended normal QQ plot of adoption level. In this plot, the x-axis represents the observed value and the y-axis represents the deviation from normal. That is DEV, deviation from normal. Here the data points are randomly scattered around the horizontal line with no clear pattern. It suggests that data follow normal distribution. And the last but not the least, this is the box plot of normal distribution. Here the median, that is middle line of the box or the thick line inside the box, represent the median of adoption level. It look like the median around 3 to 4. And the interquartile range, that is the box itself, shows the range value in the middle of 50% of the data. The top of the box is around 3.5 and the bottom is around 2.5. Hence, no outliers is appearing beyond the whisker in this plot. Overall, adoption level are somewhat centered around 3, which most values between 2.5 and 3.5. Therefore, we can assume the normal distribution. This is the statistical analysis result and graphical presentation of normality distribution. Whenever the normality assumption is proved, we can go for the parametric analysis of your research work, or otherwise we can move for non-parametric analysis. And some research scholars or authors specified the normality distribution by using skewness and kurtosis, and we can discuss in another video regarding the value of skewness and kurtosis and also the standard error calculation by using different scales. Okay, thank you for watching. If you have any query, please let me know.